The PCG L-System Tree Generation tool can be located in the content drawer under BP Procedural Generation, which is a blueprint actor utilizing the Procedural Content Generation plugin within Unreal Engine 5.2. Dragging this tool out into the viewport, this tool has all the variables preset for the user. This is to showcase an output example from the prototype. This allows the user to alter and get familiar with the tool. This tool uses the L system that takes in a user's input of strings and allows the user to control multiple transform points in three-dimensional space and generating an output mesh in real time. This tool utilizes transform points from where the mesh generation takes place and moves these transform points along the up vector. As I delete the string input and hit enter, you will notice that the mesh updates in real time within the viewport. The F character within the L system is referred to as forward, and we will input this to generate our first branch. And the tool allows you for changing the height of the branch, which relates to the distance traveled from the transform point. We can change the base radius to something like 1, change the top radius to 1, and change the height to 10. And we can see our first branch. As I added my forward command, you can see the base position transform moving up and generating a cylinder. This cylinder is made from a cone and altered by the user by setting the base radius and the top radius to be the same value. You can see I'm changing it here, and I just set it to the same value to represent a cylinder. As I mentioned previously, the height value represents both the length of the branch in addition to the distance of the base position transform that moves when commanded forward. The forward command generates the mesh based on the position and the transform of where the up vector is pointing. The way this is calculated is by taking in the rotation of the up vector and multiplying the up position by the height set and adding it onto its current position, giving its next location. So as you can see, we can alter the height and I can add on to however much I want. Next, we can explore the plus and minus angles. These refer to as the rotation within the L system and may both be set to a positive or negative value, which allows the user to have more control over the generation. So as the plus character is entered, you will notice the base position rotating by the fixed value, which allows the user to see in what direction the next branch will be generated, and multiple rotations may be added. You may also change the angle value in real time. Next, we have the X values that rotate transform arrays. You may see an array of append transforms which is generated after closing a branch. So firstly, let's open a branch by hitting the open branch character. This moved the branch position transform onto the base position transform as it copied the positional and rotational data over. And now future string inputs will alter the branch position instead of the base position. So as we make our branch, we can see that it's generating on the branch position instead. And to make an append transform, firstly let's move it inside the branch so we only rotate the branch position instead of the base position. And let's close the branch and let's make a new branch to see that the append transforms has taken the branch position data from its rotation and its position and added it onto the append transforms array. And if we do this again and we just repeat it, we can see that it makes more and more, and then once we can add the X character, it takes in the entire mesh and copies it onto the new branch, and this can be used to save time when generating and may be used to use as a reference for multiple iterations. So as the branch is made and closed, once we generate our X from that branch, it takes in the existing mesh and places it onto where the array is. and then uses that erased position and uses its up vector to generate the mesh towards that direction, and then uses the aircraft principal axes to control the roll, pitch, and yaw in what direction you'd like these to be, without affecting the turns. And if they do, it's because of the mesh that was altered. As once we start changing this mesh, you can see that it does not affect these branches unless we're copying it. This helps separate the step-by-step generation from the large-scale generation. So if we delete this branch and reset, we can actually move forward, open a branch, and use it just for rotating. And as we rotate, we can then close this branch and keep generating, and once we generate it, we can have the tree going in a different direction. And this also gives control for the user, because they also have the option to not use the X generation and just utilize based off the branches, but it does make them stick towards a 2-dimension on depending if it goes in the negative value or the positive value. If this tool were to be used in industry, I believe the best outcome of it would be if you were able to convert it into a static mesh, so a artist could take it and work with it, as then the tool wouldn't have to be used every time a user put in the PCG tool, as it would do calculations and update the mesh based on its position, and because you are moving it around, it will put load onto the computer. This also applies when using the branch data. As we close it and we copy these, when we slide this, it takes a toll on the computer. That's why it's best to just put in a value as it does it instantly, because then you're inputting through the slider many of the floats, and it's constantly taking the position and redrawing the mesh based on it. And with the many of these iterations, it'll put a lot of stress on the computer. But as you can see, as I generate the mesh, I'm saving a lot of time without having to go into any modeling software and exporting it and testing it if it's working within the engine, making it a very versatile and efficient tool. And for a prototype, I feel like it has a lot of potential to grow into a more successful tool with better implementations and giving the user more control over the rotations. Or maybe in the future, maybe some different outputs. So instead of duplicates, there could be different assets like leaves. Instead of duplicates, there could be different assets or a variety of branches with different imperfections. Or you could have the branches scaling at a smaller scale with each duplication or iteration to give it that branch effect for a tree. So I believe that the tool has a lot of potential within the future. And as it is not a strict based L system, it has a lot of potential for having more inputs and implementations, making it a interesting tool to use within development. This tool also contains a debug mode, which for every iteration and every generation, it prints out each step from the height. So it goes from 10 to 20, and you can see that going up with each input. And it also tracks the rotation, in addition to the z-axis of where it's pointing, which makes it really useful for if the widget stops working and you want it, or if you want to track the numbers of the position or the rotation. So if I start drawing, and I get like a nice branch, and I think I'm happy with it. I can start iterating more and more detail. And then I can take this and I can scale it down. Scale it down to something I'm more happy with. And as we zoom in, and as I click off, you can see that we have a nice tree. And this is how the Unreal Engine 5.2 PCG L System tree generator works. Thank you so much for watching.